the UH-2A Sea Sprite, a six-place helicopter bringing new features and higher performance to Navy utility missions. Advanced design, coupled with a gas turbine engine, delivers speeds of up to 150 knots and a range of as much as 550 nautical miles. De-icing, Doppler radar, and automatic stabilization equipment add to its all-weather capability. The watertight aluminum hull gives it a partial amphibian capability in emergencies. If needed, lateral stability is provided by auxiliary flotation bags. The UH-2A helicopter is designed for a wide variety of utility missions, such as search and rescue, personnel transfer, transportation of internal and external cargo, plane guard, and aerial photography, made easier by the almost vibration-free flight characteristic of the UH-2A. Before we take you for a flight in this new aircraft, let's look at some of its features. All major components are easily accessible for inspection and maintenance. And sections of the engine cowling actually become built-in work platforms. The power plant is a GE T58-8 turboshaft engine specially designed for helicopter use with a free turbine principle, compact but powerful, delivering better than 1,200 horsepower. It's located directly behind the main gearbox. The tail rotor is driven through intermediate and tail rotor gearboxes, each with a sight gauge for checking oil level. Control forces are greatly lightened by servo flaps on each of the main rotor blades. The blade flaps, actuated by the flight controls, supply most of the energy needed to change the pitch of the rotor blades through their aerodynamic action. The main rotor blades are constructed of aluminum and fiberglass. In a cross-section, you can see the aluminum alloy spar with fiberglass-covered aluminum blade pockets and fiberglass ribs. Tail rotor blades are of similar construction, except that the aft section is covered with aluminum instead of fiberglass. Each main rotor blade has a de-icing system, much like the hot wing system. Electric heating elements are embedded in a rubber boot at the leading edge, and the boot is then protected by a sheet of stainless steel. 8 span-wise sections are de-iced sequentially. In addition to main rotor de-icing, the UH-2A also has a windshield anti-icing system, applying heat through electrically conductive laminations in the windshield panel. Windshield washers and wipers are also installed. The fiberglass fairings on each side of the nose house the flotation bags inflated by gas generators. The tub section of the fuselage holds 2 internal fuel tanks. Droppable auxiliary tanks can also be carried on each side of the fuselage. The 4 tanks can be filled separately or through single-point pressure fueling and defueling. The retractable main landing gear folds forward into fairings below the pilot's doors. Directly above the personnel door on the starboard side is the rescue hoist mounted on a retractable boom. The 4,000-pound capacity cargo hook is permanently installed underneath the fuselage. It has an automatic touchdown release, plus electrical drop button and manual release for the pilot, also an external release for ground crewmen. Internal cargo is normally loaded through the port door, and there's also a co-pilot's door on that side. The clamshell doors in the nose give easy access to much of the electronic gear. Other electronic equipment is installed in the rear fuselage compartment. The cabin has the usual folding crew seats and cargo area, with easy access to the cockpit through the forward bulkhead. The flight instruments have been duplicated, permitting the pilots to share the load when flying on instruments. There are also 2 torque meters. The other engine and transmission instruments are all grouped toward the center of the panel. The pilot also has a fuel quantity selector switch and fuel quantity gauge, a ground speed drift angle indicator, a hydraulic pressure gauge, and two TACAN instruments, the range indicator and course indicator. Each man also has his own ICS and radio selector panels. The pilot and co-pilot can independently select their receivers and transmitters. They can hear any or all of the receiver signals at one time and can transmit on either UHF or HF or both. The ARC-39HF radio has 12 crystal control channels preset on the ground. The ARC-52 UHF set provides 18 ground preset channels, or a full 1,750 channels under manual selection. When used as a direction finder, cutting in the ARA-25A group, the bearing of the station being received is displayed on needle number 1 of the radio magnetic indicator if the selector switch is in UHF position. The same needle can also be used for low-frequency automatic direction finding. In this case, signals come from the ARN-59 receiver. The set can also be used for manual direction finding or as a low-frequency navigation receiver. Since both pilot and co-pilot have radio magnetic indicators, needle number 1 can be set for low-frequency direction finding on one instrument and for UHF on the other. Needle number 2 on both instruments gives TACAN bearings only from the TACAN receiver. This set also actuates the course indicator and the range indicator. The UH-2A also carries an APN 130 Doppler radar navigation set. This is linked to an ASA-13A navigational computer group. Also part of this unit is a tactical display plotting board. Several flight instruments are tied in, as well as the automatic stabilization equipment, or ASE. All of these are explained in detail in a separate film on navigation and instrument flight. Now let's prepare for a flight in the UH-2A. External AC and DC power connections are plugged in. This is standard procedure, even though the UH-2A has a battery start capability. There's a lot of special equipment to warm up. You'll find some new items on your checklist. Landing gear lever, down. Landing gear emergency handle, up. The rotor brake must be set in the off position so you can check the RPM range control for full and free movement. It will not turn past the idle position until the rotor brake is off. The RPM range control replaces the old throttle now that you have transitioned to a free turbine engine. Be sure that you put the rotor brake on again. Check the movement of the collective pitch lever and operate the yaw trim switch to be sure that the directional pedals respond to it. Also check the cyclic trim switch to see that the cyclic stick responds. The fuel gauge totalizer shows the total amount of fuel. The pointer shows the level in the sump tank as all fuel is transferred there before being fed to the engine. The pointer can be switched to any of the other tanks, including the auxiliaries. Check them all. In the test position, both pointer and totalizer should move toward 0. This means that the gauge is working properly. Check the caution light panel on the overhead console by pushing the master caution light test bar over the engine instruments. All caution lights will go on if the circuits are operating. Test the fire warning light, too. Turn on the hydraulic actuator switch. Although a part of the ASE system, it also delivers hydraulic boost without the ASE and makes the helicopter easier to fly. Be sure the tail wheel is locked. Turn on the battery switch, whether or not you're using external power. Turn on both generator switches. Next, the fuel pumps switch. Then test both pumps to be sure that the fuel transfer light has not come on, indicating that one of the pumps is not working. Now, fuel transfer from all tanks is automatic. Check the following switches on the emergency panel: fuel jettison, RPM control, oil shutoff, and fuel shutoff. They should be at the normal aft position. Now you're ready to start the engine. The starter is a trigger under the pilot's collective. During the start, watch two instruments, the turbine inlet temperature gauge and the gas generator tachometer. When gas generator RPM reaches 18 to 20%, start fuel flowing by rotating the RPM range control to idle. Do not start the fuel, however, if turbine inlet temperature is above 100 degrees. Light-off should occur before gas generator RPM reaches 23%. The gauge should then stabilize at between 45 and 60%, depending on outside air temperature. If you fail to get a light-off, release the starter within 30 seconds, and do not try more than 3 starts in a 30-minute period. There's the light off. At 46% gas generator RPM, release the starter. Now check your gauges to be sure that they're all within operating limits. Gas generator RPM, okay. Turbine inlet temperature, normal for idling. Engine oil pressure, okay. That's all there is to it. After the usual precautions, you'll be ready to engage the rotors. Rotor brake off. During engagement, make sure that you get immediate rises in reduction gear and transmission oil pressures, then a gradual increase to operating level. Avoid sudden application of torque. Rotate the RPM range control smoothly towards fly until the torque meter reaches 15 to 20 psi. Adjust the RPM range control until the rotor RPM reaches 90 to 92%. By that time, the range control will be at the fly position. You can now get ready to taxi. Make your usual checks of flight controls and the other items on your checklist. Don't forget to check out the ASE as instructed. If you're going to taxi, disengage the ASE after the check. Your RPM range control is already at the fly position, but you can make finer adjustments with the RPM switch. For taxiing, rotor RPM should be at a minimum of 90 to 92%. Use about 25 psi torque for taxiing, depending on gross weight, terrain, and wind. Make sure that your landing gear and auxiliary drop tank safety pins have been removed. Don't try to taxi with the collective all the way down. This would require large displacements of the cyclic stick and would impose unnecessary strain on the rotor hub. Lock the tail wheel before takeoff. Normally, you'll engage ASE now. It's not necessary, but it does make the aircraft easier to fly. The RPM range control remains in fly position. Use the RPM switch to increase RPM to 100%. Then check freewheeling by retarding the RPM range control. Marry the needles by returning the RPM range control smoothly to fly position. You're ready to take off. On takeoff, a small droop in rotor RPM is normal. The ASE is operating, but you can override it with the regular control. Remember, pull up those wheels. The maximum speed for raising the landing gear is 60 knots, and that's also the best climb speed. Throughout the speed range of this helicopter, from 0 to 150 knots, you'll experience a whole new feeling of smoothness and low noise level. With the basic ASE engaged, the UH-2A is stabilized on the existing heading, airspeed, and roll attitude. Altitude and ground speed stabilization could be introduced, but we deal with those in another film. The ASE can also be disengaged in flight, either by switching to standby here, or by use of the disengage buttons on either cyclic stick. The aircraft is now under manual control, but still with hydraulic boost. This also can be disengaged, either at the actuator switch or on the pilot's collective pitch lever. Even now, only light control forces are needed because the servo flaps do most of the work aerodynamically. Incidentally, blade tracking on the UH-2A is automatic, done by activating motors at the blade roots. You don't have to worry about ground adjustments or cockpit switches, although you do have them in case of a serious out-of-track situation. Approaches in this helicopter are routine. RPM control is automatic. Complete the before landing checkoff list. You can lower the landing gear at any speed under 80 knots. A visual check does not tell whether the gear is locked. Check the light in the landing gear handle and your panel indicators. Landing the UH-2A is routine too. It is designed to be laterally level in a hover. Simply maintain a constant attitude and reduce collective pitch. Be smooth and deliberate. The aircraft will touch down slightly tail wheel first. After landing, decrease RPM to minimum. Turn off all navigation and communications equipment before shutdown to prevent damage when power is turned on again. Disengage the rotors by twisting the RPM range control to idle. When the droop stops are in, stop-cock the engine by turning the range control off. Put the rotor brake on gradually. Then cut all switches. Your first flight will be an easy one if you've checked all systems and procedures in the flight manual. The UH-2A brings higher speed, longer range, and all-weather capability to Navy utility helicopter missions. And it brings easier handling and smooth performance to the men who fly it.
You may not think about it much, but in the event of a crash or emergency landing, the lives of survivors may depend on aviation life support equipment. ALSI. Since lives may depend on it, it is important that ALSI be serviceable at all times. This program is an introduction to ALSI maintenance for aircrew personnel. It will include 1, pre-flight inspections of some basic ALSI items, and 2, cleaning procedures. Items discussed include the CWU-27P coverall, Flyers fire-resistant gloves, summer and winter flight jackets, Flyers insulated boots, SPH-4 flight helmet, SRU-21P survival vest, and individual hot, cold, and over-water survival kits. Prior to every flight, aircrew members are responsible for inspecting basic ALSI flight clothing, including the CWU-27P coverall, a flame-retardant but not fireproof garment meant to provide protection in an aircraft fire. For a pre-flight inspection of the coverall, check all slide fasteners for proper function and operation. Inspect Velcro fastener tapes and snap fasteners for proper attachment. Check entire coverall for soil, open seams, small tears, holes, or snags. Make sure the coverall is clean. If JP4 fuel, grease, or other combustible material is embedded in the fabric, these agents will burn even though the coverall will not burn until a higher temperature is reached. The coverall may be laundered at home or in a commercial type washer in water up to 140 degrees Fahrenheit maximum. Coveralls may require several washings to ensure all fuel is eliminated. Wash until fuel smell is gone. Fabric softener may be used. Tumble drying up to 180 degrees will not damage or shrink the coverall. It may also be drip dried. Ironing is permissible, although wrinkles are hard to remove due to the fire-resistant material. Before flight with the GS/FRP2 Flyers fire-resistant gloves, check for holes, tears, and snags, and missing or broken stitches in finger and thumb areas. Check elastic wrist for proper elasticity. Make sure gloves are clean and have no smell of fuel, which will burn at its normal flash point. To clean, launder the gloves at home or in a commercial type washer in water up to 140 degrees, but do not bleach. Tumble drying up to 180 degrees will not damage or shrink the gloves. To avoid excess wear, make sure there are enough articles in the wash to absorb tumbling shock. You may also don the gloves and wash with soap and water as if washing your hands. Rinse. And squeeze the gloves to remove water, but do not wring or twist. To dry, you may place each glove flat on a towel and roll the towel, making sure the gloves do not touch. The CWU 36P Summer and CWU 45P Winter flight jackets provide protection in aircraft fires, and the winter jacket provides protection at low temperatures also. Inspect them for defects as you did the coverall. Clean the summer jacket as you did the coverall, but commercially dry clean the winter jacket when cleaning is needed. The FWU 3P Flyers insulated boots will protect against cold weather and are water resistant. Inspect them for defects and clean and polish them if needed. Normal shoe polish is acceptable. Altering the boot, such as adding a zipper or changing the tread, is not authorized. In a crash landing or during in-flight buffeting, the SPH-4 flight helmet will distribute and absorb impact forces. Ensure it is serviceable before flight so that it can help you if required. Inspect the visor lock to make sure it locks the visor in a retracted position. Lower and raise the visor to make sure it moves freely in its tracks. Inspect it for dust, grease, and other defects. Make sure the shell is clean and has no defects. Inspect for loose or missing screw. Inspect the chin strap for frayed stitching or a defective fastener, buckle, or fabric. Inspect the retention assembly for torn fabric, damaged fasteners, or a defective buckle. Inspect the suspension assembly for tears, rips, unraveled stitching, defective buckles, and damaged or missing hardware. Inspect cross-web straps for fraying, loss of elasticity, defective buckle, or other obvious damage. Inspect the ear cup cushion for tears and deterioration. Make sure earphones are properly seated and ear cup pads are soft and pliable. Inspect the liner for looseness, cracks, gouges, stains, dents, or deep depressions. Inspect the beading for looseness or deterioration. Inspect the microphone assembly for looseness. To clean the SPH-4 helmet, do not use solvents, thinner, or harsh chemicals. Clean it and the visor with mild soap and water, and make sure to use a clean, soft cloth on the visor. The SRU 21P survival vest is a complete survival package, which must be completely inspected to include all its components every 120 days by an ALSI technician. However, prior to wearing it, the aircrew member must perform a pre-flight inspection of the vest itself. Check it for holes, cuts, tears, burns, and broken or loose stitching, defective slide fasteners, and torn or missing fastener tape. broken or missing thong on the slide fastener. Loops missing from loop adjustment webbing. And loop tape cord broken or missing. Also, check the condition tag on the vest to see if the 120-day inspection to be performed by an ALSI technician is overdue. The individual hot climate survival kit is another survival package containing items such as an insect head net and a sun hat. In addition to such things as a first aid kit and canned drinking water.